I dabbled in that a bit and had some fun with it.
Do you have
But
some Bitcoin implanted in your body somewhere? You can't tell where. Yeah,
yeah,
that's
actually,
great.
yeah. It was, the modern day equivalent of finding change in the sofa cushions.
Yeah.
After I put some orphan crypto on there that I thought was worthless and forgot about it for a few years, went back and found that some community of people loved it
Mhm.
and had propped up the value of it. And so it had gone up 50-fold.
Wow,
So there was a lot of change in those cushions.
that's hilarious.
But the primary use case is mostly as a tech demonstrator. It has my business card on it. You can scan that in by touching it to your phone. It opens the front door to my house. Whatever simple stuff.
But it's a cool step. It's a cool leap to implant something in your body. I mean, it has perhaps it's a similar leap to a Neuralink because for a lot of people, that kind of notion of putting something inside your body, something electronic inside a biological system, is a big leap.
Yeah, we have a kind of a mysticism around the barrier of our skin. We're completely fine with knee replacements, hip replacements, uh, dental implants, um, but uh, there's a mysticism still around the inviolable barrier that the skull represents, and I think that needs to be treated like any other pragmatic barrier. It's the question isn't how incredible is it to open the skull. The question is, what benefit can we provide?
So, from all the surgeries you've done, from everything you understand in the brain, how much does neuroplasticity come into play? How adaptable is the brain? For example, just even in the case of healing from surgery or adapting to the post-surgery situation.
The answer that is sad for me and other people of my demographic is that plasticity decreases with age,
Yeah,
healing decreases with age.
yeah.
I have too much gray hair to be optimistic about that. There are theoretical ways to increase plasticity using electrical stimulation. Nothing that is totally proven out as a robust enough mechanism to offer widely to people, but yeah, I think there's cause for optimism that we might find something useful in terms of, say, an implanted electrode that improves learning. Um, Certainly, there's been some really amazing work recently from Nicholas Schiff, Jonathan Baker, and others who have a cohort of patients with moderate traumatic brain injury who have had electrodes placed in the deep nucleus in the brain called the centromedian nucleus, or just near central median nucleus. And when they apply small amounts of electricity to that part of the brain, it's almost like electronic caffeine. They're able to improve people's attention and focus. They're able to improve how well people can perform a task. I think in one case, someone who was unable to work after the device was turned on, they were able to get a job. And that's sort of, one of the holy grails for me with Neuralink and other technologies like this is from a purely utilitarian standpoint. Um, can we make people able to take care of themselves and their families economically again? Can we make it so someone who's fully dependent and even maybe requires a lot of caregiver resources, can we put them in a position to be fully independent, taking care of themselves, giving back to their communities? Um, I think that's a very compelling proposition and what motivates a lot of what I do and what a lot of the people at Neuralink are working for.